Before I begin, I want to reserve any and all intellectual rights I have to the ideas that I share in this presentation. That being said, none of what I plan to share is at all practical in its current state. I cannot say that everything I will present is absolutely unique or novel. However, I've invested significant time and effort into this venture, and please, if you do resonate at all with my ideas, if you are interested in discussing them or offering feedback, please engage with me either here on this channel, on social media, or our website, www.mathphysics.academy. On social media, search for us at mathphysics.academy. I would like to share a rather perhaps unorthodox proposal of mine. For some reason, I believe we, as in the educators, should start teaching first-year undergraduate students quantum field theory on their first day in physics undergrad. I've advertised this idea far and wide within my small circle of physics friends, and beyond it being an absolute hit, it seems to invoke a physicist's inner passion to educate well. The journey is a long and difficult one, and if they have any desire to be physicists in the 21st century, an early encounter with QFT and the ways in which it informs a physicist's understanding of the universe will only benefit the undergraduate. From this point on, instead of undergraduate, I will use the term level 1 and level 2 instead of graduate. We can be plenty clumsy inside of a thought experiment, but for the sake of a streamlined approach, assume the audience of level 1 students is composed of highly motivated individuals willing to collaborate, with at least a demonstrable ability to score sufficiently well in reasonable high school algebra, geometry, trigonometry, chemistry, and physics assessments, and that everyone involved can effectively intercommunicate ideas. In a university, this is, achieved on some level through an agreed choice of language, although with the advent of something like an LLM, it seems best not to speculate and rather note that translation these days is becoming incredibly cheap. As a note for later, here or elsewhere, building in room to accommodate for both the behind and ahead student, it's not an original idea of mine, but it allows for more heterogeneity in learning styles and is a fundamental goal in any program developed by MPA. The idea is that on day 1, if the level 1 student is admitted to our program, it doesn't matter if they know any quantum mechanics or not. In the first lecture on the first day, they're exposed to quantum field theory in possibly intimidating detail and tasked with confronting humanity's best scientific theories at the very beginning. I cannot offer a strong opinion at this time as to what I believe should be introduced to the students in the first sentence or the first paragraph in the first lecture, but here are some potential low-hanging fruit that come to mind. We could study the Klein-Gordon equation followed by the Dirac equation. We could study a Compton scattering experiment. We can study the Standard Model at the Large Hadron Collider and other particle accelerators. And the list ought to go on. The point is not to mind blow, as much as I love that Tim and Eric meme, but to force confrontation with what physicists know to be reality. Earlier exposure to the most successful scientific theories of humanity better enables and prepares students for their future careers. These theories are called quantum field theories, and indeed this term can take some getting used to. Indulge me a little further in this irresponsible thought experiment thrust upon the innocent minds of imaginary students. Imagine their horror. Just kidding, of course. Let us return to the possible various topics of Lecture 1 for just a moment. When I imagine a new curriculum, I admit I'm not sure how to do so at scale, or in a massively distributed manner via the internet. Perhaps this is constricting and with time can be explored in further detail. For now, my self-proclaimed thought experiment is, as I mentioned above, in a school or university where there are conceivably 3 to 4 groups of level 1 students at any given time, and 3 to 4 groups of level 2 students at any given time. In order to reach this point, of course, we would need to run the program for at least 3 to 4 years. Anyway, by the end of the first semester, by the end of the first year, there's no expectation that they reach a certain problem-solving ability for those extremely difficult problems you might find in a QFT textbook, like one of Steven Weinberg's Quantum Theory of Fields volumes. In my experience and observation, this is simply not going to be possible in general. However, by, say, halfway through their last year, Level 1 students ought to be able to reproduce their first lecture sufficiently well. This is one area where we could have variation of cohorts, as one cohort could be exposed to electron-positron annihilation, whereas another could be exposed to Compton scattering. The chosen topics do not have to be particle physics related. We could choose a condensed matter approach as well. The end goal is, perhaps vaguely at this time, for them to, quote, learn QFT, unquote, at a basic level by the end of the program. I will zoom out now and provide a glimpse of what I envision for a level 1 curriculum. I will touch on levels 2, 3, and 4 as well, but in this presentation I will focus solely on level 1 and vaguely how levels 2 through 4 support level 1. As the listener or viewer may notice, the 4 levels are modeled after the traditional hierarchy. The hierarchy of knowledge and knowledge passing makes a lot of sense to me. We have level 1 modeled after the undergrads, level 2 modeled after graduate students, 3 after postdoctoral students, and level 4 by professors. What could level 1 students possibly gain from a QFT lecture, dare I say lectures? In particular, those students who have absolutely no preparation for such an event. I have already mentioned early exposure being a benefit, but practically there is a question as to what direction we take with this. It could easily flop. I doubt that type of scenario is difficult to imagine. But this is a reckless thought experiment, so let's run with it for a minute. Level 1 students in their first year will take this course, let's call it Introduction to Quantum Field Theory, as well as others. A technical history and philosophy of science and mathematics, we'll call it HPSM, beginning in antiquity or at least around the 1600s, the time of Newton. This is a cross-listed course. It'll be required for both math and physics students. Then we would have exploratory laboratory coursework where students have room to rediscover the equations, laws, and so on that they will spend so much time learning about in HPSM. Students who desire to pursue mathematics will have different required EL coursework than the students who desire to pursue physics. We will have supplemental coursework designed for maintaining competitiveness with peers elsewhere, although the design of the program is largely focused on the end result rather than any intermediate time. There will be recitations and office hours held by level 2 students, as well as a level 2 student hosted reading session, and these reading sessions and recitations and office hours are all going to be mandatory for level 1 students. We're also going to introduce performance and reading terms, although I will touch more on this in a future video. This design lends itself to an accelerated approach to covering the century since Newton. The HPSM and EL coursework will explore these centuries in more detail throughout the program. The Introduction to QFT coursework will continue its trajectory of absurdity, but as expansive a subject as QFT is, there is ample opportunity to look at it from a variety of perspectives across the disciplines. If the goal is achieved, graduating level 1 students will have a demonstrable technical understanding of physics and mathematics since Newton. They will have experienced the slow development as well as the forced encounter with the frontier, at least the frontier of QFT. As they look forward to their future careers, be it pursuing some kind of level 2 type program, industry, or government position, They will be prepared for wherever they find their place in the dazzling time that is the 21st century. Everything I have shared here comes from my own lived experience, both as a teacher and as a student, and I have not conducted any careful experiments to confirm or support any conclusions I may have already made. I acknowledge many others out there also desire to build a new curriculum with their own approaches and opinions. I hope to encounter more perspectives in pedagogy in mathematics and physics, and I welcome feedback and criticism to my proposals and opinions, ideally in constructive form. Thank you for checking out Math Physics Academy. I hope you will consider subscribing or following us elsewhere on social media.